In this video, we're going to look at a very simple model obtained from the at-risk page with lots of model examples. And this is a model that would be used to estimate the amount of methane reserves in a coal bed. And it's really quite a simple model. Here's how it works. First, you estimate the area. We get the drainage area, or the area that contains the coal here. So A stands for the number of acres. Then we get its thickness. What's the thickness of those acres? We get the density in tons of coal per acre foot. And then we get the gas content. That's measured in standard cubic feet per ton of coal. So this, and this estimate the amount of coal. This estimates the amount of gas in that coal, and the recovery factor estimates how much of that gas we can actually recover. So you see here in the example that was prepared, once again we have non-parametric distributions. They are quite common in risk assessment work. Here we have a triangular distribution that is based on these three numbers, D7, E7, and F7. If I move this down, I can't make that little triangle disappear, so you see the distribution there. We have triangle distributions throughout. And so if we want to estimate this value here, this value, by the way, is you multiply all of these together, you divide by 1,000,000,000, and this gives us a number of, amount of reserves in billion of cubic feet of methane gas. So let's do a simple simulation now of this number. We'll calculate this 1,000 times because all of those inputs are uncertain. So once again, I remind you that anything that you do in the spreadsheet that has uncertain values in a calculation can become a risk assessment model if you are dealing with the uncertainty in a way that's going to help decision makers make decisions. So here we turn out saying there's somewhere between 0.2 billion cubic feet and as much as 15.6 billion cubic feet. Most likely we have about 4.7 billion cubic feet. So this is another simple example of a risk assessment model.